Good morning to everyone. Today we will discuss about precedence and associativity of operators and evolution of expressions, type conversion techniques. First we discuss about associativity of operators. Okay, as we know that C supports different types of operators and there must be some rule for evaluating the complex expressions. So to evaluate the complex expressions, you have to follow some rules. And to evaluate complex expressions, C has adopted two important rules, and we call them as operator precedence and operator associativity. First, we discuss about operator precedence. The operator precedence is used to determine the order in which the different operators in a complex expressions are evaluated. Okay, so this will tells which operator is to be first evaluated. Which operator is to be evaluated first. Okay, so as we know that C has different types of operators. So in this case, the operators will be executed in the following order. Okay, if expression is having different operators, okay, then the expression is evaluated based on the order of. So first we have to evaluate the unary operators, and then you have to evaluate the arithmetic, multiply, and division and modulus operators, and then add and subtract operators, and then relational operators, equality operators, then logical and, logical or, conditional operators, assignment operators, and comma operators. Okay, so in this way the operators are to be evaluated. So the higher the precedence of an operator, the earlier the execution, the earlier the expression containing that operator is evaluated. See, if this unary operator is having the higher precedence, means the operator is to be evaluated first. In that expression, the unary operator is to be evaluated first. And then you have to check for arithmetic, multiply, division and modulus operators. So in this way, the operators are to be evaluated. And next, associativity nothing but it indicates the order in which the terms in the expression are evaluated. So here associativity tells in which order the expressions is to be evaluated or the operators are to be evaluated. So this order can be of two types, either from left to right or either from right to left. Okay, so here the below table shows the arithmetic operations and the operators and their precedence and associativity. So here if you observe addition operation, okay, the precedence is 2 and the associativity is we have to evaluate the addition operator from left to right. And subtraction operator, okay, see this is having the precedence 2, okay, and then associativity is left to right. And if you consider the multiplication operator, the precedence is 1. The first precedence means you have to evaluate that operator first, okay, and the associativity is left to right. And similarly the division modulus operators are also having the precedence 1 and the associativity is also left to right. So this is the operators and these are the precedence of the operators and these are the associativity of the operators. And there are different types of operators that are available in C. Okay, see first if you consider the function call. So this is a operator used to represent the function call. So function call, the associativity of the function call is left to right, and the associativity of array subscription or array subscript is left to right, and the dot operator is having the associativity left to right, and similarly the arrow operator is also having the associativity left to right. Okay, and when it comes to the logical not operator, so it is having the associativity right to left. You have to evaluate this operator from right to left, and this is the complement, that is one's complement, so it is having the associativity right to left. And this is the minus, that is unary minus operator, or we call it as a negation operator. So this is also having the associativity right to left. And this is the increment operator, plus plus is the increment operator. So this operator is also having the associativity right to left. And when it comes to the decrement operator, it is minus minus, and the associativity of this decrement operator is right to left. And when it comes to the address of operator, so this is called address of operator. Okay, and the associativity of this operator is right to left. And when it comes to the indirection, okay, so this is the indirection operator. So this is having the associativity that is right to left. And this is data type within the bracket, the data type within the bracket. Okay, so this is called cast operator, cast operator. So this is having the associativity right to left. And another operator, this is size of, is one operator. Okay, the size of operator having the associativity right to left. And when come to the multiplication operator, okay, it has the associativity left to right. And the division operator, this is also having the associativity left to right. And this is the modulus operator, so this is having the associativity left to right. And when it comes to this addition operator, so this is having the associativity left to right. And the subtraction operator, so this is having the associativity left to right. And this is the left shift, this is called left shift operator, so this is having the associativity left to right. And this is the right shift, so this is having the associativity left to right. And this is the less than symbol or less than operator, so this is having the associativity left to right. This is less than or equal, okay, this operator is having the associativity left to right. And this is the greater than symbol, and this is the greater than or equal, so this is also having left to right precedence, left to right associativity. And this is equal to operator, so this is having left to right precedence, associativity. And not equal, so this is having left to right associativity. And this is the bitwise and so it is having left to right associativity. And this bitwise XOR, exclusive OR XOR, so this is having the associativity left to right. And this is the OR, bitwise OR, this operator is having left to right associativity. This is the logical AND, it is also having the associativity of left to right. This is the logical OR, so similarly this is also having the associativity left to right. And this is the conditional operator, question mark colon. Okay, so this is also having the associativity right to left. So these are the different, it is having the associativity right to left. And all the compound assignments, all the compound assignments are having the associativity right to left. And the comma operator is having the associativity left to right. So this is about the associativity of various operators. And next we will see how the expression is evaluated in C, how the C compiler will evaluate the expression. So while evaluating an expression, C compiler follows hierarchy rules. So it follows the rules. Okay, the expression is scanned from left to right. So if one expression is there, that expression is scanned from left to right. And while evaluating an expression, the operator with higher precedence will be evaluated first. If the operator is having the higher precedence, then we have to evaluate that operator first. And then the second highest precedence operator is to be evaluated. Okay, and the least precedent, if the operator is having the least precedence, then it is evaluated at last. Okay, so here the division multiplication, division and modulus are having the higher priority, and plus, minus, addition, subtractions are having the lower priority than multiplication, division and modulus. And if parenthesis is encountered, then the expression within the parenthesis is evaluated first. If there is a parenthesis in the expression, that parenthesis is to be evaluated first. See, for example, if you consider expression, that is x minus y by 3 plus z into 3 minus 1. This is one expression. It is having the variables, symbols and constants. That is, it is called expression. Expression means which is having the variables, symbols and constants, and operators also. It is the operators. Okay. See here, consider x value has 3 and y value has 9 and z value has 7. Okay. So here this expression is evaluated in following phases. See first. See here, first of all, the division operator is to be evaluated first. The division is having higher priority, so we have to evaluate the division operator first. So in this expression, we have to scan this expression from left. So this is from left side, left to right. We have to scan from left. So in this, the division operator is having the higher priority. So first we evaluate the division operator. The result of 9 by 3 is 3. Okay. So in this step, the expression is evaluated. This expression is evaluated as 3 minus 3 plus 77 into 3 minus 1. Okay. So, and then the highest priority is multiplication. Okay. See here, from left to right, if you scan, the multiplication is having higher priority. So we have to evaluate the 77 into 3. And the result of this 77 into 3 is 231. Okay, so this is one level. So in this level, what we do is, see, if you scan from left to right, okay, here the minus operator is having the higher priority. Minus is having the higher priority among this minus plus minus. The minus operator is having the higher priority. Okay, so here what we are doing is, we are evaluating this 3 minus 3. And the result is 0 plus 231 minus 1. So after this step, here the plus operator. Here this, among these two operators, the plus operator is having the higher priority. So we are adding 0 plus 231. That is, the result is 231 minus 1. Okay, and here finally this is the minus is having the least priority. So we are evaluating this minus at last. See, the result of 231 minus 1 is 230. So in this way, this expression is evaluated. Okay, and the result is 230. Okay, so that all this explanation is shown in this figure. So first here we evaluated 9 by 3, and then we evaluated 77 into 3, and then we evaluated, that is 3 minus 3. Okay, and here we evaluated, okay, 231 plus 0, and then we evaluated 231 minus 1, and finally it is 230. Okay, so in this way the expression is evaluated. So another example is that, so we are taking the expression like 5 into 4 by 2 plus 5 by 5 plus 8 minus 2. Okay, so here if you observe here, we have to scan the expression from left to right in this direction, left to right. So first we have to evaluate the multiplication operator. The multiplication operator is having the first priority. So 5 into 4, the result is 20. 20 by 2 plus 5 by 5 plus 8 minus 2. After this step, so here the division operator is having the higher priority. From the left to right, whenever we are scanning this expression, we are having the division operator at first level. See here we have to evaluate this division operator. So 20 by 2, the result is 10. 10 plus 5 by 5 plus 8 minus 2. Again we are having the division operator. Okay, so this, among these operators, the division is having the higher priority. plus division plus minus. Among these operators, the division is having the higher priority. So because of that, we are evaluating 5 by 5. That is 10 plus 1 plus 8 minus 2. So after this, among these operators from left to right, the plus is having the higher priority. So we are evaluating 10 plus 1. The result is 11 plus 8 minus 2. So after this, among this plus and minus, the plus is having the higher priority. So 11 plus 8, the result is 19. 19 minus 2. See, after this step, this is having the least priority, minus is having the least priority. So 19 minus 2, the result is 17. So in this way, this expression is evaluated and the result is 17. So let us consider another example here. See here, A is greater than B within the bracket, a logical and here it is C is greater than D. Okay, so this is the expression and we are taking the values. A value has 10, B value has 12, C value has 12 and D value has 13. So here first we have to evaluate the expression which is in the brackets. So this is in the bracket and this is in the bracket. First we have to evaluate these two expressions individually. 10 is greater than 12 is one expression and 12 greater than 13 is one expression. So here 10 is greater than 12, so this is false. This is false. A logical and 12 is greater than 13, so this is also false. So false, logical and false, the result is false. In the logical and case, both should be true, then only the result is true. For remaining cases, the result is false. So here both are false, so the result is false. Okay, the result for this expression with these values is we are getting the result as false. Okay, so what we are doing here, we are evaluating the expression which is in brackets first. So this is in bracket and this is in bracket. We have to consider these as individual expressions and then we have to evaluate it. Okay, so the result is false. And next we discuss about type conversion techniques. Okay, so type conversion is nothing but converting a value or converting a data type, okay, from a value from one data type to another data type. Okay, converting a value or a variable from one data type to another data type is called type conversion. There are two types of type conversion techniques out there. One is implicit type conversion, another one is the explicit type conversion. So first we discuss about implicit type conversion. Okay, so this implicit type conversion is also called as coherence. Coercion, it is also called as coercion, and sometimes it is also called as automatic type conversion. It is called as automatic type conversion. So here, if the operands are of different types, the lower type is automatically converted to higher type. Okay, the lower data type is automatically converted to higher data type. That's we call it as the automatic type conversion. Okay, and the result is of higher data type. Okay, if the expression is having the lower data type and higher data type, then it is evaluated to higher data type and the result is also in higher data type. Okay, so if you consider here 3 plus 2.0, so this is the double value, this is the integer value. So among the integer and double is having the higher, we call it as the higher data type. Double is the higher data type. So the result of the 3 plus 2.0 will result into 5.0. Why? Because 2.0 it is a double data type. The result is also in double data type only. Why? Because the double data type is having the higher priority compared to the integer, we call it as the integer data type. Okay, so here the result is 5.0 since 2.0 is having the higher is the higher data type. Among these two, 2.0 is the higher data type. So in this way 3 plus 2.0 is evaluated to 5.0. And next we discuss about explicit type conversion. Okay, so this explicit type conversion is also called as type casting. It is called as type casting. So casting can be used to round off a given value. So here what we do is we round the value. Casting is used to round a value. So for example, if you mention a integer data type within the bracket and then 22 by 10, okay, the result here after evaluating the 22 by 10, the result will be actually it is in float. But if you mention int in the bracket, the result will be integer result. Okay, so here we are getting 2 as the or 2 as the result for this example. Okay, by why? Because here it is having the type casting. So this is called casting operator. Okay, this is called casting operator. So this is the cast operator. We call it as the cast operator. It is having the associativity right to left. Okay, so in this way, so this is evaluated to 2. The result is 2. So here the operator used to force the conversion of a value to another type is called cast operator. So here what we are using? We are using the cast operator. This operator is converting this value to this data type. So this is the syntax, or we call it the general form, within the bracket data type and then expression. So this is the data type and this is the expression. 22 by 10 is the expression and this is the data type. It is the data type. So this is the explicit type conversion, and here see data type is one of the standard C data type, and the expression may be a constant, a variable, or an expression. So this can be of any data type and this can be of any expression or any value. So here, so A is the double value, that is 6.5, and B is also a double value 6.5. So what this expression is telling here is the cast operator with int, okay, A plus the cast operator with int B. See, this converts a 6.5 to integer, and this converts the 6.5 into integer. The integer equivalent for 6.5 is 6, and the integer equivalent for this 6.5 is also 6. And the result here we get the result as 12. 6 plus 6, that is 12, not 13, not 13. So if you write normal a plus b, then the result is 13. But what we are doing here, we are using the cast operator. So this cast operator, okay, converts this 6.5 to 6 and this 6.5 to 6, and the result is in integer result, that is 12. 6 plus 6, that is 12. Okay, so some other examples are shown here. Okay, and the following rules have to be followed while converting the expression from one data type to another data type to lose the information. So while converting, there is a chance for data loss. So then we have to follow some rules here. All integer types to be converted to float. Integers are to be converted into float, and all float types to be converted to double. Integers are to be converted to float and floats are to be converted to double. Okay, and all character types must be converted to integers. All character types are to be converted into integers. Okay, so this is for today class. Thank you to everyone.